Okay, hello students. So in the last class, I have already discussed about some rules which are used for drawing the ray diagrams in case of spherical mirrors. Now today we got to consider about the characteristics of images formed by concave mirrors. Okay. So today we are discussing about concave mirrors. Later we got to discuss about convex mirrors as well. So concave mirrors are converging in nature. This you already know. Another thing what you know is uh, you know that when a ray of light is parallel to the principal axis, it passes through the focus. That is one rule, isn't it? When a ray of light passes through the center of curvature, it goes undeviated. That is what you know. Next, now when a ray of light is parallel to the principal axis, it passes through the focus. That is fine. That is fine, no problem. When a ray of light passes through the focus, it emerges parallel to the principal axis. These were the three rules which I had told you in the preceding lecture. Now today we are considering the position of objects at different places. The objects are placed at different locations, and we are concerned about the type of image that it will produce. So today's lecture will be based on that. So I have drawn three different cases. I have taken three different cases of objects placed at different positions, and we got to understand the nature of image that it will form. Okay, if the object is there, object is placed at different positions. In the first case, we are considering the object at infinity. Infinity in physics is a very long distance which can be approached. As in mathematics, it's undefined. So that is why mathematicians, they say it is undefined. For physicists, it is a very long distance. So I have taken a very long distance. So I have taken a dashed line. You can see so objects. So light rays are coming from far away. That is, object is placed very far. Okay. So when light rays are coming from far away, light ray is parallel to the principal axis. It comes here. You can see the arrow. It passes through the focus. Very fine. Light ray parallel to the principal axis passes through the focus. So the point where these rays are actually meeting, you can see these rays are actually meeting at this point. So when the rays of light, they actually meet at a point, that type of image is called a real image. So here we will get our image, and the image will be a point image. Okay. So where is the position of the image? The image is positioned at the focus. Are you understanding? The image is formed at the focus. You can see it here. And as the image is formed by the actual intersection of the light rays, okay, the image is real. And obviously concave mirrors, they produce inverted images, and this is a point image. As you can see, that means it is highly diminished. Diminished means very small. Point, you can see. Now let's bring this object more closer towards us. Let's bring this object here, beyond the center of curvature. We have not reached the center of curvature. We have brought the object from infinity to here, beyond the center of curvature. The story remains the same. Ray of light parallel to the principal axis passes through the focus. Fine. Ray of light parallel to the principal, ray of light passing through the focus emerges parallel to the principal axis. You can see these arrows are very important. Ray of light passing through the focus emerges parallel to the principal axis, and you can see this is where the rays are meeting one another. So this is the position of the image. So where is the image located? The image is located between C and F, that is between the center of curvature and the focus. Fine. This is very important from an examination point of view, and this may be asked. What is the characteristic? Obviously, actually the image is formed by the actual intersection of the light rays, so it's real. Obviously you can see it is inverted and diminished, smaller than the object. Fine. Next, let's bring the object even closer. C. We have brought the object here at C. Ray of light parallel to the principal axis passes through the focus. Ray of light passing through the focus emerges parallel to the principal axis. This is the point of intersection, and here is where we get our image. Where is the image? The image is exactly at the center of curvature. The nature is real inverted, and the size is exactly same as that of the object. Okay, it's neither diminished nor magnified. So what we are seeing here is when we are bringing the object closer and closer towards the mirror, the image is the image is getting farther and farther away. Obviously you have seen it in your plane mirrors also. If you move closer, you just see someday in some type of mirrors, those are actually concave mirrors. If you move closer, the image will appear farther and farther. So that is, the object is coming closer and closer. Initially the image was here. Now as the object has come closer, the image is formed a bit further. The object is here again, closer here, moved by this much distance. The image has come even further. Okay. Now consider three more cases. So after having discussed the three cases, so here we are bringing the object even closer. So in the preceding case, that is the third case, we had kept our object at the center of curvature. Now we are keeping the object between the focus and the center of curvature. So the story remains the same. When a ray of light parallel to the principal axis passes through the focus, no problem. A ray of light passing through the focus emerges parallel to the principal axis. This is the point of intersection, as you can see, and here is where we get our image, isn't it? So the image is slightly magnified, bigger than the object. You can see it's obviously inverted and real. Why real? Because it's formed by the actual intersection of the light rays. Very simple. Where is it formed? It's formed beyond C. As you can see, when you are bringing the object closer and closer, the image is going further and further. So now, next case. If you bring now the object at the focus, okay. So if the object is brought at the focus, ray of light parallel to the principal axis passes through the focus, and a ray of light incident at the pole again gets converged, you can see. And the image, you can see, it's not being formed here. It will be formed at a very, very large distance at infinity. Please remember this special case. The image is formed at infinity and it's real inverted, and if it is at infinity, it will be highly, highly magnified, isn't it? Isn't it? See, with passage of time, it will meet somewhere here, suppose. So it will be highly magnified. The image will be highly magnified. Now a very, very special case here, when the object is placed between the focus and the pole. That is when the object is placed within the focal length. This is what is called within the focal length. When the object is placed within the focal length. What is focal length? Focal length is the distance between the pole and the focus. Hope you all remember this. So when the object is placed between the pole and the focus, that is the focal length. Ray of light parallel to the principal axis will pass through the focus, that is fine. Ray of light incident at the pole will get converged and it will get reflected in this manner. Now what happens, very interesting phenomena takes place. The image is formed behind the mirror, you can see. The image is formed here when the object is placed within the focal length. This is very important. Okay, so this is the only case where a concave mirror produces a virtual image. Why virtual image? You can see the light rays are not actually meeting at a point, but they are appearing to meet, isn't it? We have brought this ray backward and an image is formed here. Are you understanding? So the image is not formed by the actual intersection of the light rays. So this type of image is called virtual image. Are you understanding? And it is shown by dashed line, as you can see. So, and virtual images are upright. Always remember, real images are inverted and virtual images are upright. Okay, this you have to remember. So virtual image, it's upright. So the only special case of a concave mirror when it produces a virtual and upright image is when the object is placed within the focal length. So here I have discussed different positions of objects and characteristics of images formed by virtue of the changing the position of objects. What we saw was with the decreasing, that is with the decreasing distance of the object towards the mirror, that is when the object is coming more closer and closer to the mirror, the image is going more further and further away. And in the last case, we got to see a virtual image which was formed due to the position of the image being located, position of the object, beg your pardon, being located within the focal length. So these are the different cases. Now they have specific applications in different optical instruments. This you can go through it on your own, and when later on when we discuss lenses, I'll talk about this in more details. In the meantime, Hope you all have understood this. So this was a very laborious task for me to draw the ray diagrams. So I recommend you to use skills and do the necessary construction which are required for explaining this, explaining and understanding these facts. So thank you so much. See you.